Troubleshooting a bathroom lighting circuit where there is no power can be approached systematically. Since voltage is present on the load side of every circuit breaker in the subpanel, the issue likely lies within the circuit itself. Firstly, focus on open neutrals. Use a multimeter to check if the neutral wire is continuous from the subpanel to all switch boxes and light fixtures. An open neutral is a common culprit that prevents voltage from reaching the switches and fixtures. A break anywhere in the neutral wire can cause the entire circuit to fail. Secondly, thoroughly inspect all wires for damage. Carefully examine the wires throughout the entire circuit for any cuts, nicks, or other forms of damage. Even a small break or compromised section can interrupt the flow of electricity. Pay special attention to areas where wires may have been stapled or come into contact with sharp edges. Thirdly, test the switches and light fixtures themselves. Disconnect the switches and light fixtures from the circuit and then use a multimeter to check for continuity across each switch and fixture. Replace any defective components that are not functioning correctly. Switches can fail internally and light fixtures can develop shorts or open circuits. Fourthly, meticulously check for loose connections. Double check that all wire connections in the subpanel, all switch boxes, and all light fixtures are securely tightened. Loose connections can cause intermittent power issues or a complete lack of power. Ensure that wire nuts are properly sized and tightened, and that screw terminals are snug. Fifthly, inspect the wiring sequence at each connection point. Verify that the wiring sequence, meaning hot, neutral, and ground, is correct at each and every connection. Incorrect wiring can lead to no power or, more dangerously, create electrical hazards. Miswiring is surprisingly common and can easily disrupt the circuit's operation. Sixthly, use a multimeter to test for voltage at the terminals of the switches and light fixtures. This helps to pinpoint whether the problem is located between the switches or further along the line at the fixtures. If you find voltage at the switch terminals but not at the fixtures, the issue lies in the wiring between those points. Seventhly, check for short circuits. Use a multimeter to check for short circuits between the hot and neutral wires. A short circuit can prevent voltage from reaching any of the switches or fixtures down the line. This is because the short creates a low resistance path, causing excessive current flow and potentially tripping the circuit breaker, although the breaker isn't tripping in this situation. Eighthly, inspect all junction boxes along the circuit. Open any junction boxes along the circuit and visually inspect the wiring inside for any loose connections, damaged wires, or any signs of overheating. Junction boxes are common locations for wiring issues to develop. Look for discoloration or melted insulation as signs of overheating. Ninthly, consider the possibility of hidden problems. If all of the previously mentioned steps have been completed and the problem still persists, consider less obvious issues such as damaged wiring within walls or ceilings, or potentially faulty wiring from a previous installation. Rodents can sometimes chew through wires inside walls, creating hidden breaks or shorts. Tenthly, when dealing with electrical circuits, safety is paramount. If you are not completely comfortable with electrical work, it is always recommended to contact a qualified and licensed electrician for further troubleshooting and repairs. Electricity can be dangerous, and it is best to leave complex issues to professionals. Now, to elaborate on some of these steps with more technical detail. Firstly, when checking for open neutrals, use a multimeter set to the continuity setting. With the circuit to energized, test between the neutral wire of the subpanel and the neutral wire at each switch box and light fixture. A reading of infinite resistance indicates an open neutral. Even a partially broken neutral can cause issues, so it's important to inspect the wire visually for any signs of damage. Secondly, when inspecting wires for damage, pay close attention to areas where the wires pass through metal studs or joists. These areas are prone to damage from chafing or improper installation. Look for any signs of exposed copper or damaged insulation. If you find any damaged wires, replace them with new wires of the same gauge and insulation type. Thirdly, when testing switches and fixtures, use a multimeter to check for continuity with the switch in both the on and off positions. In the on position, there should be continuity, and in the off position, there should be no continuity. For light fixtures, check for continuity between the terminals and the fixture's metal housing. If there is continuity, it indicates a short circuit. Fourthly, when checking for loose connections, use a torque screwdriver to ensure that all screws are tightened to the manufacturer's recommended torque specifications. Over-tightening screws can damage the terminals, while under-tightening can lead to loose connections. Fifthly, when inspecting the wiring sequence, ensure that the hot wire, typically black or red, is connected to the switch's line terminal. The neutral wire, typically white, should be connected to the fixture's neutral terminal. The ground wire, typically green or bare copper, should be connected to the fixture's ground terminal or the metal box. Sixthly, when testing voltage at the terminals, use a multimeter set to the AC volts range. With the circuit energized, carefully test the voltage between the hot and neutral terminals. You should read approximately 120 volts. If the voltage is significantly lower or zero, there is likely a problem upstream. Seventhly, when checking for short circuits, use a multimeter set to the resistance or ohms setting. With the circuit energized, disconnect the hot and neutral wires and then test the resistance between them. A reading of 0 ohms or very low resistance indicates a short circuit. Eighthly, when inspecting junction boxes, look for signs of overheating, such as melted wire nuts, discolored wires, or a burning smell. Overheating can be caused by loose connections, overloaded circuits, or short circuits. If you find any signs of overheating, replace the affected components and investigate the cause. Ninthly, when considering hidden problems, it may be necessary to use a wire tracer or tone generator to trace the wires through the walls and ceilings. This can help you locate hidden splices or damaged sections of wire. Additionally, consider the possibility of faulty breakers in the subpanel, even though voltage is present on the load side. Breakers can sometimes fail in a way that allows voltage to pass through but cannot carry a load. Finally, remember that working with electricity can be dangerous. Always to energize the circuit before working on it, and use appropriate safety equipment such as insulated gloves and eye protection. If you are not comfortable with any of these steps, it is best to call a qualified electrician. To expand further on the initial troubleshooting steps, let's consider some more advanced techniques and potential issues. Firstly, regarding open neutrals, it's crucial to understand that an open neutral can create a phantom voltage effect. This means that a multimeter might show a voltage reading, but the circuit won't be able to carry any significant load. This is because the voltage is essentially floating, without a complete circuit to allow current to flow. Therefore, always test the neutral wire under load if possible. You can do this by connecting a test light or small appliance to the circuit and then measuring the voltage. If the voltage drops significantly under load, it's a strong indication of an open neutral. Secondly, when inspecting wires for damage, pay attention to the type of wiring used in the circuit. Older homes may have aluminum wiring, which is more prone to corrosion and loosening at connections. If you find aluminum wiring, use special connectors and antioxidant compound to ensure proper connections. Also, be aware of the potential for asbestos insulation in older wiring. If you suspect asbestos, do not disturb the wiring and consult with a qualified professional for safe removal or encapsulation. Thirdly, when testing switches and fixtures, consider the possibility of three-way or four-way switches. These types of switches are more complex than standard single-pole switches and can be more difficult to troubleshoot. Make sure you understand the wiring configuration of these switches before attempting any repairs. Additionally, check the voltage rating of the fixtures and switches to ensure they are compatible with the circuit voltage. Fourthly, when checking for loose connections, use a wire gauge tool to ensure that the wires are properly sized for the terminals. Using too small of a wire can lead to loose connections and overheating. Also, be careful not to over-tighten screws, as this can strip the threads and damage the terminals. Fifthly, when inspecting the wiring sequence, pay attention to the color coding of the wires. In North America, the standard color code is black for hot, white for neutral, and green or bare copper for ground. However, in some older installations, the color coding may not be consistent. If you are unsure of the wiring sequence, use a multimeter to identify the hot, neutral, and ground wires. Sixthly, when testing voltage at the terminals, be aware of the potential for induced voltage. This is a small voltage that can be induced in a wire that runs parallel to another energized wire. Induced voltage can sometimes cause false readings on a multimeter. To avoid this, try to measure the voltage with the circuit under load. Seventhly, when checking for short circuits, consider the possibility of a ground fault. A ground fault is a type of short circuit where the hot wire comes into contact with the ground wire or a grounded metal object. Ground faults can be dangerous and can cause electric shock. If you suspect a ground fault, use a ground fault circuit interrupter or GFCI tester to check the circuit. Eighthly, when inspecting junction boxes, look for signs of improper wiring practices, such as wires that are not properly spliced or wires that are not protected by conduit. Improper wiring practices can create electrical hazards and can also lead to circuit failures. Ninthly, when considering hidden problems, it may be necessary to use a thermal imaging camera to identify areas of overheating in the walls or ceilings. Overheating can be a sign of damaged wiring or overloaded circuits. Additionally, consider the possibility of rodent damage. Rodents can chew through wires and insulation, creating hidden shorts and open circuits. Finally, remember that electrical work requires knowledge, skill, and caution. If you are not comfortable with any of these steps, it is best to call a qualified electrician. Do not attempt to repair electrical problems if you are not properly trained and equipped. And also, be mindful of local electrical codes. These codes are designed to protect people and property from electrical hazards. Make sure you are familiar with the electrical codes in your area before attempting any electrical work. Moreover, if the bathroom renovation or electrical work was done without permits or proper inspections, there could be code violations that contribute to the problem. Unpermitted work can often lead to unsafe wiring practices that are not immediately apparent. It's worth checking local records to see if the electrical work was properly permitted and inspected. If not, it might be necessary to bring in an electrician to bring the wiring up to code. And also, consider the age of the wiring. Older homes often have outdated wiring systems that are not designed to handle the electrical demands of modern appliances and lighting. If the wiring is old and brittle, it may be more prone to damage and failure. Replacing the wiring may be necessary to ensure the safety and reliability of the electrical system. And lastly, check the ampacity of the circuit breaker. Make sure that the circuit breaker is properly sized for the load it is carrying. If the circuit breaker is too small, it will trip frequently. If the circuit breaker is too large, it will not provide adequate protection against overloads and short circuits. The size of the circuit breaker should be determined by the ampacity of the wires in the circuit in accordance with the National Electrical Code Table 310.15b16.